So here we letting W be x squared plus y squared, with x and y being i.i.d, with a Gaussian distribution, mean 0, standard deviation, variance 1. So the MGF we told of x2 turns out to be this term here. We're asked to find the MGF of W, and then afterwards we're going to figure out what famous distribution that we have studied W follows. So let's start with the first one, the MGF of W. So that we write out as we define an MGF, which is a function of an arbitrary parameter t, and that is, by definition, the exponential of t w, and w is, as we are told, x squared plus y squared, like that. The following. Now we use the properties of the exponential to write out y on with its own base, and then we're going to use that x2 and y2 are i.i.d, which gives us the opportunity to write out the exponentials, multiply out the x and y's as two expectations, like that, like the following. Okay, should be a 2 here, and we also know that x2 has this MGF, and because y squared is essentially a mirror of x, it will also have the same MGF. So we have then 1 minus 2t, 1 minus 2 for the first MGF. I'm going to take that squared because we have 2 of them, and this then simplifies to 1 minus 2t minus 1. This is then the MGF of W. Moving further to the second part of this exercise, we are now asked to figure out what famous distribution that we have studied is this term here. And this is in fact something that is quite difficult to figure out by just staring at this term here without having some pattern recognition, some memory of what this MGF is. But yeah, so what we do here is that, I mean, this is in fact an exponential, it turns out to be, and so having going back and looking at the MGFs that we've worked with, this is in fact how I solved this problem. So this is not obvious, but let's see how this actually turns out to be an exponential. I find these types of questions a little hard to work with because they rely on memory or even deeper pattern recognition that is difficult to build up when you're just getting into the whole MGF world. But let's at least see what this MGF, how the exponential MGF looks like. So here we're going to then proceed by taking defining the a variable z that is exponential. param to half lambda, then evaluate this expression and see how we end up here. E to the t z. And this is now lotus, meaning that we can take this transformed version and multiply it by the PDF of exponential half. That will be then z half evaluated over z. We can now take out the constant, and by the rules of the exponential, write e to the z minus z half. This looks awfully close, similar to z, so I'm going to write it again there as z2. And now take out the z minus to make sure that the properties of the let's see, so it'll be a half minus t dz, making sure that this looks like an exponential and not taking out a plus z here. Otherwise we're flipping the support. And now then evaluate this integral to the following. So just by the rules of the integration, finding whatever constant that cancels out this term here. Well, it should be these z, which we evaluated, should be like this, and proceed by let's take out this constant here like this, and then evaluate the limit z going to infinity. This is just e z 1 to minus t. Evaluate the other limit. Like that. And this whole thing becomes equal to 1. And this we see we're multiplying dividing by a very large number becomes 0. Okay, so then we end up having so let's just simplify this term here by factoring out a minus 2. And so that is then minus half minus half here, and then we have a now let's see, we have a 1. Well, let me just check what is it that we're going to well, we want it to be let's see, we want it to be a minus, let's see, minus, I want a minus sign at the t, so we want to make sure to not extract let me see, remove this minus here and keep the well, now I'm doing several things simultaneously, and I see an error has crept in to this whole thing. This minus sign is obviously not at, it's at the whole expression here, and that we keep like this, minus then 2t multiplied by minus 1. This is what is left from this expression here. And so this cancels and that cancels, and we end up having the expression that we indeed were looking for, and this is then the in fact the MGF of z exponential half.